They're everywhere, on our skin, in the soil, in the oceans, even inside us. Bacteria. For billions of years, they've shaped the planet. But now, through the power of genetic engineering, they're doing something extraordinary. They're working for us. In the 1970s, a medical revolution began. Before then, insulin, the drug essential for millions living with diabetes, came from pigs and cows. It was expensive, limited, and sometimes risky. Then came a breakthrough. Scientists reprogrammed E. coli bacteria to produce human insulin. For the first time, a microorganism was turned into a medicine factory. It was a turning point. Suddenly, we weren't just studying bacteria, we were designing them. That single innovation changed the pharmaceutical world forever. Insulin was only the beginning. Soon, engineered bacteria were making human growth hormone, offering new hope to children with stunted growth. They produced erythropoietin, or EPO, helping patients with anemia. Today, bacteria churn out vaccines, antibodies, and even cancer-fighting drugs. These microbes are like microscopic factories. We design the blueprint, and they do the hard work of manufacturing complex proteins we could never make on our own. From diabetes to cancer therapies, bacteria have become silent partners in saving lives. But the power of bacteria doesn't end in the clinic. Industries are learning to harness them for energy and materials. Engineered strains can convert agricultural waste into biofuels like ethanol and hydrogen, sustainable alternatives to fossil fuels. Others produce biodegradable plastics designed to replace petroleum-based plastics and reduce pollution. Imagine a world where your shopping bag, your packaging, even parts of your car could be grown by bacteria instead of made from oil. And when disaster strikes, like an oil spill, engineered microbes may hold the key to cleaning our oceans. In agriculture, bacteria are transforming the way we grow food. Traditional farming relies heavily on fertilizers, chemicals that harm the environment. But engineered microbes can fix nitrogen naturally, feeding plants without the damage. We're designing microbes that live with the crops, protecting them from pests and providing nutrients. It's like giving the soil a living immune system. One famous example, Bacillus thuringiensis, or BT, its natural insect-killing protein has been engineered into both bacteria and crops, protecting harvests worldwide. The future, even more remarkable. Some bacteria are designed to produce vitamins like B12 at industrial scales. Others act as biosensors, living devices that glow in the presence of toxins or disease markers. We can now program bacteria almost like computers. We write code in DNA, and they execute it in the real world. This could mean bacteria that diagnose cancer inside the human body, or microbes that monitor pollution in real time. But with such power comes responsibility. Genetically engineered bacteria raise concerns about safety, environmental impact, and ethics. Could a modified strain escape and cause harm? Should we rely so heavily on engineered life? We're playing with powerful tools. It's not just about what we can do, it's about what we should do. Scientists are developing strict safeguards, kill switches, genetic locks, and careful regulations. The goal is to ensure that these microscopic allies remain safe partners.